So we had dilute today as an adjective, a dilute solution, modifying, telling me what type of solution I have, a modifier. Okay, but what does dilute mean as a verb? If I gave you a solution and I said, I want you to dilute this, what would you do? What would you do to make it a more dilute solution? You'd add more solvent, right? You add solvent. Okay. So, let's stop and think about what doesn't change when I add water to a solution. What doesn't change? How much stuff I have in the solution, right? The solute doesn't change when I add water. So that means that the number of moles of solute doesn't change. The grams doesn't change. The moles don't change. My Kool-Aid tastes bland, though. Yeah. So I'm going to write this as an equation. I'm going to write this sentence right here as an equation. It's complicated. The moles before equal the moles after. And how can I figure out moles in a solution? Well, if I want moles, well, my only definition I have that has moles in it is molarity, right? And molarity is moles over liters. So if I want moles, I'm going to have to multiply both sides by liters, right? So that means I get to change this equation to this. M1V1 equals M2V2. Because M1V1 would be the moles before, right, Christian? M2V2 would be the moles after, and they have to equal each other. What kind of relationship is this? Well, because if I have more volume, I'll have less molarity, right? This looks just like Boyle's law, except it's not for gases. Okay. M is concentration, V is volume. As you read through homework and you read through the book, you're going to find that they refer to something called a stock solution. And they're using the word stock like Amazon uses the word stock. Okay? Stock means it's sitting on the shelf ready to be used. It's just pre-made to a known molarity. When I order hydrochloric acid, I have my choice about what concentration I order. I can order 0.1, 0.2, 0.5, 1, 3, 4, and 12 molar hydrochloric acid. I always order 12 molar because I can make all the other ones from the 12 molar. If I buy the 1 molar, I can make the less than 1 molar, but I can't make the more than 1 molar. So I buy the most concentrated stuff and dilute it down. Yeah. So when they say stock solution, all they're saying is it's sitting on the shelf ready to use. Somebody's already pre-made it to a known concentration. So there's nothing different about that solution other than it's sitting on a specific shelf. It's what you have available to you. Okay, so 2 liters of a 0.88 molar solution are diluted to 3.8 liters. What is the new molality? One volume, one molarity, second volume, they ask me for the second molarity. Anybody know an equation with those pieces in it? That's M1V1 equals M2V2, and I want M2. So I need to divide both sides by V2. So my M2 is going to equal M1, 0.88 molar, times V1, 2.0 liters, divided by V2, 3.8 liters, and 0.88 times 2 divided by 3.8 is 0.46, and the units are molar. Now we can check, does this answer make sense? The volume went up, so the concentration should go down. Fact is, the volume almost doubled, so the concentration got cut almost in half. See how those numbers work out there? So it's the same type of thing. Now let's kick it up a notch. You have 115 milliliters of 6 molar HCl. What volume of 1.3 molar HCl can you make? They give me one volume, one molarity, second molarity, and they ask me for the second volume. So M1V1 equals M2V2 again, except this time we want V2, so I divide both sides by M2. Will not let me write an M down there. I write it? Oh, let's let that one stay. I don't know why. So V2 is going to equal, I know I want M1 to be 6.0 molar, but the question is, can I do this in milliliters? Let's find out, because I'll just do it twice. Once in milliliters, 150 milliliters, and once in liters, which is 0.15 liters. Both those I have to divide by 1.3 molar. So in the first instance, 6 times 15 divided by 150 divided by 1.3, and I get 690 milliliters. If I do that numbers with the bottom one, I get, meters cancel off, and I get 0.69 liters. Did I have to change? No, I didn't have to change, because 0.69 liters is 690 milliliters. Right? So this will work in milliliters. Right? It'll work in milliliters. Okay. I run into this all the time. I have to make the solutions you want, and I only buy 12 molar hydrochloric acid, so I always have to dilute it down. I always have to ask myself this kind of question. How much do I need? Like in tomorrow's lab, I know I need 2 liters of solution to make it through the day. Okay, so how am I going to make that? So if I have 450 milliliters of a 0.15 molar NaOH, and all I have is a 2 molar stock solution, how do you make the required solution? Well, I got 2 molarities and 1 volume, so I'll be able to find the second volume. Everybody okay with that? So that V2 is going to be M1 V1 over M2, which is 0.15 molar times 450 milliliters divided by 2.0 molar. 0.15 times 450 divided by 2, and I get 34 milliliters. And you circle that answer, and Mr. Green marks it wrong. How do you make the required solution? 34 milliliters. See why that's not the answer? It's part of the answer, but it's not the answer. Okay, that's 34 milliliters, so here's how you would make the solution. You would take 34 milliliters of 2 molar and add water until you reach the 450 milliliter mark. Period. That's what you do. And you might say, well, you add 430 milliliters of water. Volumes are not additive. You say, oh, of course they're additive. No, they're not. And so, we're so used to things being added up, but it doesn't work quite as well as you think. So here I'm going to take 50 milliliters of water. Right at 50. And 50 liters of methanol. I can't pour it out of here very well, so I'm going to pour it into a beaker first. Do, 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 do. A little bit more. Okay. So, I have 50 milliliters of water. Is that 50 milliliters? Is the bottom of that curve right on 50? Yeah, is that 50 milliliters of this? Got 50 and 50. So, of course, 50 and 50 makes 97. It's only 97. It's not 100. Volumes don't add. That's why you have to word it that way. That's why you can't say add 430 milliliters. Or, does that make sense? You can't say add 416 milliliters. Because volumes don't add the way you think they're going to. Notice we have never said volume is conserved. We've always said mass is conserved. Particles are conserved. Volume's not conserved. It can change. So that's why you got to write it that way. I got to end up at 450. Make sense? Okay. So this is the kind of thing I have to do all the time for your labs. You needed 3 molar hydrochloric acid. How did I make it? So what'd you get? M1 V1 over M2. It's going to equal V2. So that was 3.00 molar times 5.00 liters divided by 12.6 molar. So 15 divided by 12.6 is 1.19 liters. That's as hard as it gets. Okay. But we got to tie this into the moles of the compound is not going to be the same as the moles of the ions.